Imagine a world where the very sky is saturated with the stench of primordial chaos, and the clouds are woven not from life-giving moisture, but from the suffocating vapors of the abyss. In the silent void of space, far from the familiar warmth of our sun, drifts a colossus cloaked in a toxic veil, a world that defies everything we thought we knew about planetary formation. This is not merely a celestial body, it is a monument to the universe's grand alchemy, where the light of distant stars meets chemical madness to forge a landscape worthy of Dante's darkest visions. For eons we have gazed at the night sky, wondering if we are alone in this infinite ocean of lights, searching for worlds like our own, cozy, cradle-like, teeming with water and oxygen. But the cosmos has proven to be a far more inventive and frankly terrifying decorator. Humanity's most powerful eye, the James Webb Space Telescope, has peered into the void, spanning light years of distance to unmask the true face of one of the strangest exoplanets ever detected. What it saw forced scientists to hold their breath. Before us stood a giant whose aroma, could we but smell it, would instantly transport us to the maw of an active volcano or the foulest pits where matter itself decays. This planet is a hot Jupiter, a gas titan, orbiting its parent star so closely that the very concept of time is warped. A year on this behemoth lasts only a few Earth days, and atmospheric temperatures soar to levels where metals would turn to vapor. Yet heat is not its most defining feature. The true mystery lay hidden within the spectral lines, the invisible codes of light that the telescope decoded with haunting precision. Scientists discovered hydrogen sulfide, the very gas we on Earth revile for the stench of rotten eggs, the scent of rot and volcanic eruptions. Picture yourself gliding through the upper layers of this atmosphere. Instead of an azure sky, you are enveloped in a thick yellowish-brown haze, illuminated by the violent flares of a nearby star. There is no solid ground to stand on, only an eternal plunge into a maw where pressure mounts by the second, crushing space itself. Winds howling at thousands of miles per hour carry this toxic plume across the entire hemisphere, turning the planet into a gargantuan, open-air chemical laboratory. It is a world that smells of death, and yet it is vibrant in its geological and atmospheric fury. How were we able to smell this world from hundreds of light years away? It seems like magic, but in truth it is a triumph of human genius. As the planet passes in front of its star, the starlight is filtered through its atmosphere. Every chemical element, every molecule leaves its unique fingerprint, its shadow within that light. James Webb caught these shadows, and among the usual suspects of methane and water vapor, it captured the unmistakable signature of hydrogen sulfide. This discovery marks the first time in history we have found such definitive proof of this gas on an exoplanet. Sulfur is a fundamental building block of the cosmos. It resides in the proteins of our own bodies and fuels life in the deep-sea vents of our oceans. But here, in this fiery realm, it acts as the master architect of a nightmare. Why does this matter to us, the tiny inhabitants of a pale blue dot on the other side of the galaxy? Because sulfur is the key to understanding how planets are born. It tells the story of exactly where in the protoplanetary disk this giant took shape. Much like an archaeologist reconstructing ancient civilizations from shards of pottery, astronomers use the concentrations of sulfur and carbon to trace planetary migration. This toxic titan wasn't always this close to its sun. It was born in the cold, dark fringes of its system, where sulfur froze into ice before being lured by gravitational dances into a fatal inward spiral, devouring everything in its path until it became locked in this hellish orbit. The temperatures at the surface, if one can call these dense layers of gas a surface, exceed 900 degrees Celsius. At such heat, the chemistry we consider normal breaks down. The clouds here likely consist of silicates, essentially microscopic particles of sand or molten glass, falling through the lower depths as scalding rain. Combined with the stench of sulfur, it paints a portrait of a true underworld as envisioned by ancient mystics. Yet, for science, this isn't hell. It is a rare window into the backstage of the universe. We are beginning to realize that the diversity of worlds in the cosmos is far broader than we ever dared to imagine. There are ocean worlds, diamond planets, and then there are these, stink planets, which, despite their repellent aroma, carry the purest scientific truths. Investigating this planet raises profound new questions. If sulfur is so prevalent in the atmospheres of hot giants, how does it affect the potential for life in more temperate systems? We know that on Earth, sulfur was the fuel for the very first organisms long before oxygen graced our atmosphere. Could there be worlds where what we consider a toxic stench is the scent of life? Places where chemical mists sway instead of forests, and creatures breathe what we would call poison. For now, these are but whispers of theory, but every object found by James Webb makes these whispers a little more tangible. We are standing on the threshold of an era where we will know not just the size and mass of distant planets, but their scent, their color, and their weather patterns. We are learning to read atmospheres as easily as we read the local weather report. And this toxic world is but the first chapter in a new book of discovery. It reminds us just how extreme nature can be. The universe is under no obligation to be comfortable or sensible to us. It is majestic in its indifference to our standards of luxury, and that is exactly what makes it so breathtaking. Every time we point our telescopes into the dark, we expect a miracle, but we find something far more complex, the raw mechanics of reality. Our journey to this hellish world has come to an end, but our exploration of the cosmos is only just beginning. Every discovery like this is a brick in the foundation of our understanding, how out of the chaos of gas clouds and stardust, worlds are born, where someone might eventually look up at the stars and ask, why? No matter how terrifying these distant planets may seem, they are part of our shared history, the history of the very atoms that make us who we are. Thank you for embarking on this journey with me. Your curiosity is what drives science forward across billions of miles of empty space. If you enjoyed this deep dive into the mysteries of exoplanets, don't forget to support the channel. It helps us bring even more epic stories to life. Hit the like button and share your thoughts in the comments. What do you think the perfect planet would smell like? Subscribe so you don't miss our next expeditions to the furthest reaches of existence. Stay with us. There is so much more to uncover. Until next time, we'll see you among the stars.